As I mentioned at the end of the previous video, we've got to make sure that any information coming to our router is the latest and greatest information before we overwrite the information that we already have. And with OSPF, that's all about the LSA sequence number. And when an OSPF enabled router receives an LSA, first it's going to check that OSPF database that we just looked at for any pre-existing entries for that link. And here comes an LSA for 172.12.23.0/27. The receiving router says, let me check my database for that same entry. Now, if there is not an entry for that link, it makes sense. The receiving router will make one in its database, and then we'll flood that LSA out every OSPF enabled interface except the interface the LSA wrote in on. That sounds pretty familiar, right? Familiar behavior. But if there is an entry for the link, the sequence numbers come into play. So we could be higher, we could be lower, we could have a tie. If the sequence number of the incoming LSA is exactly the same, then that LSA is ignored and no additional action is taken. That's pretty rare though. It's usually a higher lower deal. Now if the sequence number is lower on the incoming LSA, what happens is the router that receives that one ignores the update and transmits an LSU containing an LSA back to the original sender. And basically the router with the most recent information is telling the original sender, hey, you sent me old information. Here's the actual latest info on that link. Now, should the sequence number be higher, that's what the router is actually looking for before it overwrites its own information. So at that point, the router adds the LSA to its database and sends what we call an LSA ACK. And it's actually, LSA acknowledgement, of course, back to the original sender. The router will then flood that LSA and update its own routing table by running the SPF algorithm against the now updated database. So there's a lot going on behind the scenes with our routing table in OSPF that we simply do not see with RIP and EIGRP. Now, once that initial exchange of LSAs takes place, there will not be another exchange unless there's a change in the network topology. And this being networking, there's one exception. An OSPF speaking router will send out a summary LSA every 30 minutes. So that's not a bad deal at all, especially when you look at RIP and it's 30 seconds. So that's how our table gets built. And we've got to have the adjacency first, though. And here, let's go back and talk about this adjacency a little bit, and then we'll see some of it in action. OSPF speaking routers, before they can really do anything else, they have to become neighbors by forming an adjacency. And they have to agree on certain things. And with different protocols, different services that have the adjacency in there, of course, the values will be different. The routers in this case with OSPF must agree on the area number. They have to agree on hello and dead timer settings and whether the area is a stub area. Again, if you're not familiar with stub area, don't worry about it. That's why I'm here. You're going to be. But I have to mention this now since we're talking about adjacencies. If we have set up any kind of link authentication, then as you would expect, it has to be configured on both sides of the adjacency. Now this process number we're talking about here, I'll actually show you exactly where that comes in. It comes in at the very beginning of our config. Sorry about my moving there. You're likely familiar with a command like router OSPF 1 or 4 or something like that, but that number right there is the process ID. This number does not have to match between potential OSPF neighbors. It's locally significant only. And for that reason, it doesn't have to be agreed upon for the adjacency to form because the downstream router isn't even going to know what the local router is using for a process number. Now, the heartbeat of OSPF, it's the hello packet. OSPF relies on hello packets for two very important tasks. First, dynamic discovery of potential neighbors, and we like that, and also the renewal of existing adjacencies, because like so many other things in Cisco land, once the adjacency is formed, it's not forever. There has to be some kind of keep alive, something that keeps saying, hey, I'm still here, hey, I'm still here, and in this case, hey, I still agree with you on the adjacency factors. So in this case, the adjacencies have to be created, but they also have to be regularly renewed. Now, OSPF-enabled interfaces are going to send hello packets at regularly scheduled intervals, and those intervals differ depending on the network type. Now, on an Ethernet-based segment, which we'll see in action, an OSPF broadcast segment, hellos are going to go out every 10 seconds. So that dynamic neighbor discovery happens pretty quickly. On serial links, they're sent less often. They're sent every 30 seconds. OSPF hellos have a destination IP that you should see before your eyes when you close them at night and go to sleep, and that is 224.0.0.5. That's an address from our Class D range, our multicasting range, that being 224.0.0.5 is a multicast address. Now, the neighbor relationships, they're kind of like neighbor relationships involving human beings. Just because someone moves in next door, that doesn't automatically make you neighbors. You might be adjacent, but you're not neighbors. They may do something you don't like. They may have noisy parties, they don't mow the lawn, they play their music too loud. There's some factor that you don't agree with. Well, I think you should mow your yard, more often than once every 3 months. And the neighbor says, no, well, you're not really going to be neighbors. You'll just be adjacent. Well, that kind of thing happens with routers because they have to agree on basic values before they become actual neighbors. And we want to have these values down cold for your exam in real world networking, because a lot of OSPF issues that creep in, especially with adjacencies, I guarantee you, they're going to come back to the simple little fixes and the simple little connect values that we're going to look at in the very next video, because these are simple fixes for adjacencies. You just have to know where to look, and I'll start showing you where to look and take a look at these factors at the beginning of the very next video. See you there.